Welcome everyone to the Early Career and Student Statistician Network event, and also the event of the New Zealand Statistical Association. Together, the SSA and the New Zealand Statistical Association are jointly presenting this webinar given by Emi Tanaka entitled An Academic Journey in Pursuing the Art of Statistics. My name is Luca Maestrini, and I'm the representative for the Canberra branch of the Statistical Society of Australia, particularly the representative of early career and student statisticians. And as a representative of the SSA, I would like to acknowledge also the traditional custodians of country throughout Australia, where I'm sitting here today, and their connections to land, sea, and community. We pay our respect to the elders, past and present, and extended respect to all Aboriginal and Torres Strait Islander peoples today. As I said, the webinar, as you know, is given by Emi, and so I would like to give a brief introduction to her, and also say that at the end of the webinar, we will spend a few minutes to talk about our mentoring program. So stay tuned after the webinar ends. Emi told me to give her a short introduction, but I think she deserves a few more words than she expected, perhaps. So I will spend like a couple of minutes introducing her. First of all, Dr. Emi Tanaka is a senior lecturer in statistics at the Biological Data Science Institute of the Australian National University in Canberra, and she also holds a joint appointment at the Research School of Finance, Actuarial Studies and Statistics of the ANU. Her primary interest is to develop impactful methods and tools that are ready to use for practitioners. And to this end, she has developed numerous open source tools, primarily as R packages. And I can personally say that she's probably one of the best R programmers in the country here in Australia. Emi is also the Vice President of the Victoria and Tasmania branch of the SSA and a council member of the International Biometric Society for the Australasian region. Her contributions have been recognized with the SSA Distinguished Presenters Award, the SSA President's Award for Leadership in Statistics, and she's been featured in the list of 60 prominent Australian statisticians that has been put together by the Significance magazine. There is certainly more we could say about Emi and her brilliant career, but she will tell us more during her presentation. So I think I can now pass it on to Emi. Thank you, Emi, and feel free to start. Yeah, thank you.
Thank you, Luca, for the kind introduction. Also, thank you to Daniela for the invitation. I'm very pleased to be able to, see a lot of people here. I actually expected a smaller crowd, and so hence I actually kind of thought about having it more like a conversation style. And so I actually don't have any fancy slides. I still kind of want to keep it in some ways a bit flexible, so that way I'm actually addressing maybe things that, particularly early careers, if you want to know something, or if you have any kind of questions, like feel free to kind of interrupt me as I go through. And so I do have a bit of an outline, and I'll expand and go through a bit of my journey, but part of me, I have to say, I was kind of writing these dot points because it's a lot about my journey. It did feel a little bit self-indulgent because it's all about talking about me, but I do want to kind of emphasize that, this is like a early career session, and particularly we want to make sure that early careers actually, feeling like they're part of the community. So like, feel free to definitely interrupt me to make sure that you're getting something out of it. So as I have in my notes there, I am going to be sharing my journey, but like I think everyone does have a unique journey. So just because it's different to yours, I don't think like, you should try to be like me or otherwise. Now, based on what I put out, I did say this is about pursuing the art of statistics. Now, just to kind of give a bit of a background, so we're on the kind of same page. When we say art, well, if you look out for definition, there isn't actually like an agreed definition of what constitutes to be art. Wikipedia says like, art is something that stimulates an individual's thoughts, emotions, beliefs, or ideas through the senses. I asked ChatGPT, and ChatGPT was art is a creative expression and communication of ideas, emotions, or experiences through various mediums often possessing aesthetic and interpretive qualities. Now, when I put out the abstract, you probably have seen what I kind of thought of what the art of statistics is. But I think this is sort of like similar to the general definition of art, where it doesn't really, like, there isn't a concrete definition to it. And maybe what's considered art is really conditioned on the creator and the viewer. So what I put out there was that, you know, in the abstract, which you may have already read, that the art of statistics involves the creative and interpretive elements of working with data. And it can include like human judgment, intuition, understanding in the statistical process of communication, and that ultimately feeds as input for conducting the science part of the statistics. And some of the concrete examples I gave was things like when we make some kind of decisions during the pre-processing stage, so the cleaning of the data, and also like when we are trying to define the data structure for study design. So this can be either like for things like experimental design, where you kind of need to understand from the domain expert what the structure is before you kind of try to generate experimental design. So there's that part of before you go to do the algorithmic part, which is more associated with the science, you kind of need to have that basically understanding of really what the data is about in the first instance, or potential data that you're going to collect and answer the question for. And then there's also things like interpretation of statistical results. Now, there's this part about the philosophical experiment that says that if a tree falls in a forest and no one is around to hear it, doesn't make a sound. And in part, I kind of always think about this with statistics research a lot, where there's a lot of clever people who come up with really smart statistical methods, but it's written in a way that's meant for statisticians and not for really the consumers of statistics. And so sometimes you get somebody will create something, but people who actually need it don't know it exists. So often I think of like part of the art is really like, you know, trying to actually make use of some of the existing statistical methods and connecting it down to people who actually, you know, need it. And in some ways, art is like, you know, an expression of like the beauty, perhaps of the world or some kind of opinion and so forth. And that's kind of put in a concrete way so that people can kind of see it as well, right? So some way like the art of statistics, in my opinion, is that we kind of have that statistics, but put in a way that other people can grasp of it. So in that sense, like the art of statistics I'm talking about is more kind of rooted in practice of statistics itself. Now, you might have a different definition yourself, but that's sort of like what I'm going to be talking about, essentially as I go through my journey. Okay. So before I go on and talk about it, I just thought that maybe you can kind of see what like my main kind of driving factors are, like what I think about most as I go through my journey. And some parts have become a little bit more concrete than others. So I think from the very beginning, I kind of really had this part where I want to be a useful human being. So I kind of like, you know, always think about how does my skill set actually contribute to within whatever the context, that could be the profession, society, or culture. And generally I want a win-win situation. And then I want to go into a gap where I can have the most impact. Now, as it went through my career, you will come to see this as I talk a little bit more about my journey. And if you know me, I get a little bit frustrated with poor statistical practice to the point that I really want people to do better. So there's a part where I want statistical literacy and practice on average for the population to actually be raised up. So, you know, that is more because I just can't stand reading these journal articles one after another, where I feel like the statistics was done poorly. So the other part you will find out is that I do have a bit of a focus on the computational product itself, and I see that as part of research. Now, a lot of the time when I do it, I do kind of think about what sort of the actions needed, and I don't like to think about it just wishful thinking. So I'm a bit more action oriented rather than just like talking about it and nothing happens and we keep on complaining about the same issue over and over again. So there's some parts where I actually try to take an action, so that because I want to change certain things. And particularly what I have really done a lot more, because I thought it kind of is the way to go, was doing a bit more open science and then doing a lot of open source software development. So that kind of links back to like my primary agenda there, where like essentially if I want people to do better, I share what I have done so that they can copy whatever is useful for them and take it with them. Linked to that is also like I did a lot of work and still kind of center and think about the community building. I want to kind of have a space whereby more people can kind of see that beauty of statistics, because a lot of the time I feel like statistics for the general population doesn't actually get a lot of love. Somehow people don't really feel like they can get into statistics. And so kind of want people more in general to see like there is actually beauty in statistics, and then also that they can do it as well. My career-wise, I actually haven't really focused on paper publications, although like I do keep it in mind. So because I am an academic, and you know, if you are in academia, you kind of know that is actually the metric people go by. So I kind of tick the box to make sure I'm not going to be fired, but I don't actually do a lot of emphasis on this part. In terms of interests, well, I actually, since childhood, was very interested in art. And in fact, my childhood dream was to actually be a manga artist. I just never decided to go through with this because of the fact that actually my art skill itself is actually not very good, and I was better in mathematics. So I figured, okay, yeah, look, I think there's not very good chance that I can actually get a job becoming a manga artist. And also, like, you know, in the end, I wanted to be useful in some ways. So I thought, you know, doing something that I'm good at will be probably the way to go. I really like to learn. And then so I read a lot of nonfiction books and autobiographies as well as biographies. And I have a couple of books written there. I really liked The Outliers by Malcolm Gladwell. That gave me a bit of a perspective of like a world. And Malcolm writes interesting things. Outliers sound statistical, but actually it's not. Like it's more like a there is some data, but like it's not really statistical. But that's interesting if you want to have a read. And there's another book called The Happiest Man on Earth by Eddie, and that was really, really good as well. But part of why I'm sharing this is that actually there's a lot of like parts where I'm curious about certain rationale or motivations behind decisions that make. And that kind of feeds in. You might see this a little bit in my research as well. And this is sort of like, this is my interest, and it wasn't really the statistic, like my work related interest, but that actually kind of fed into my own work in certain ways as well. Research interest wise. So I am interested in experiment design, mixed models, data visualization, visual inference, bioinformatics, selective breeding when it comes to application, very much into statistical software development, and also what I call statistical workflow. And this is kind of encompassing things like reproducibility, design, infrastructure, and communication. So it's not something that really is traditionally associated with statistics, particularly mathematical statistics, but it's sort of something that I think a lot about because of the fact that I think if you want to get information out of the data, actually the life cycle of data means that you actually need to, you know, be able to access it. And then to model it, you need to clean it. And so like there's a whole process to it. And then once you get to modeling it, you need to then interpret it and then communicate it to people who need the results, right? So like, you know, there's a part where I thought, like, because I really like making that impact, I felt like to connect everything, kind of need to really know the whole thing. So I do actually emphasize a lot. Like if for students I supervise, they all have to do like reproducible way of writing their thesis. They have to use version control. So this is like a strong emphasis, and although it's not like a traditional statistical area, it's something that I actually am very interested in how people actually kind of project manage and cognitively manage essentially their projects. Now, given that, let me go through how it went. And again, feel free to interrupt me if you want to know more parts of it. Now, in undergrad, so I decided to do maths and stats as major because I know that I can't be an artist. I will not be able to get a job. And during that time, and you'll see that I'll emphasize like the computational language I was using, just so you can see my involvement as well of the usage of computer. During that time, I learned Java, R, MATLAB, and Fortran. And so I learned a few different languages, but I actually wasn't really proficient in any. And before undergrad, I've never done really programming, so to speak. My first statistical job was just before my honors, the summer period. I had a job at USyd's NHMRC Clinical Trial Center doing biostatistics. And at that place, I learned and used SAS. And it was kind of clearly obvious to me that even though I have done maths and stats major, I'm pretty bad at the real data analysis because one of the time I actually had to compare the means of two groups. And what happens is that it was some t-test. I don't have the exact recollection, but what I remember was that there was a significant difference between the group. But later, when computing the numerical summary, I realized that there was actually an outlier in the data. And then it didn't occur to me that I should be looking, at the distribution of the data, checking assumptions and things like that. I think at that point, I kind of knew how to do the formulaic way of the statistics. So it's more the science part of it, but without really having that deep understanding of like how, like connects with the data itself. So I thought I was pretty like useless in that sense. I didn't know a lot of things still. And I felt like, okay, look, I think I still need to learn stats. And then I was already enrolled in to start honors. So I did honors in stats. And then like, even after honors, I still thought that, okay, I still don't really think I can be like a person who can advise people how to do statistics. So let me go on and do a PhD if I get the scholarship. And so it was lucky that I got the PhD scholarship, and therefore I started my PhD. And my focus really from get-go was really applied statistics. I went away from mathematics because it wasn't too clear to me how math gets used in practice, like at least directly. But statistics was a lot more easier for me to see, like that it can be used for like the companies or other people to make sense of data. So that's where I stuck in it. And naturally, like what I wanted to do was more applied statistics. And particularly, I actually wanted to do something computational. I liked programming, and I wanted more opportunity around that. So PhD was in more like a niche bioinformatics area. And it is quite niche. The title of my thesis was Improving Statistical Methods for Motive Evaluation. And it can kind of be summarized for those people who don't know what a motif is in the context of the bioinformatics. It's basically particular sites in your DNA, whereby basically it characterizes like certain certain function. So in this case, I'm looking at the transcription factor binding site. So this is where the protein will actually bind onto your DNA. And then so the problem I worked on is really centered around when you got a Curie motif that you find, like you're going to actually search to see if there's something significantly similar in existing motif. So here it was actually very much in the science part of it, because it was trying to improve the calculation for the p-value, such that it's biologically meaningful in a certain sense as well. It was quite niche in this area because it's a very particular focus. But I had actually no biology background. I didn't do biology in my HSC. I didn't do any biology in undergrad. So it was a little bit of a learning curve for me because I had to pick up the biology side of things. And so I learned a fair bit. And during this time, what happened was that I actually switched to using Python because I found the string manipulation at the time in R not as easy as in Python. And then I thought, okay, Python might be what I want to use. So throughout my PhD, it was a combination of Python, and then I had to use the clusters. The school had clusters, and I run a lot of intensive simulations. So I did a lot of Bash and using HPC. So quite a lot of good concrete skill set there. And then I think I learned quite a lot. My PhD supervisor, Uri Kesh, was a very deep thinker, and he had high integrity. And definitely I actually saw how to do research a lot from him. But where I think didn't quite fit me well was that he was very, very deep and good, and he always got things right. But it was too niche for me, and I was more like a broad person in the way that I work. So in some sense, it didn't quite fit my style. And then also I wanted to work on more different kinds of projects as well. But nonetheless, he was a very good supervisor, and I did learn a lot during that process. But after doing PhD, still learn, I was still not confident I can be on my own. And so that's where I felt like I needed to do a postdoc. And so so there was a couple of different opportunities. So one was at the medical school at UNSW, and of course they wanted a statistician, and I didn't want to go, if I needed to have a job, I guess that was an option, but I felt like I want to learn from other statisticians because I don't feel like I knew the science enough, and the science of statistics enough. And so instead of going for that, where I become the statistical expert, I wanted to be in a place where there's other statisticians around. And luckily I had an offer from the University of Wollongong. There was a Center for Biometrics and Bioinformatics, and I had a 3-year postdoc under Professor Brian Collister. And this, I have to say, is a super life-changing moment for me. Because Brian was actually, before actually joining University of Wollongong, he used to be in the Department of Primary Industry. So he has a little bit of non-standard career path. So he wasn't quite a standard academic in some sense. So he had actually a lot of good experience working on really with external clients. And in particular, he was heading up the statistics for the Australian grains industry project. And this is where really I learned a lot about selective breeding, as well as, complex experimental designs like multi-phase designs, as well as designs for field trials, and then complex kind of mixed models essentially. So during this period, I learned a lot, like quantitative genetics, selective breeding, mixed models, experimental design, and a bit more like about the agricultural grains industry as well. And also, it was during this period, in order to fit a lot of the complex mixed models, I did have to go back to R. So I stopped using Python and then went to R during this time. So particularly, I think what I liked about this was the different range of like projects that's available, and also that immediate like application. And actually the fun part about working with things like field trials or plant breeding is that I feel like you know the results very quickly. And then you can kind of see the output in certain ways. I thought this area was really, really fun. And in fact, I was actually surprised that in the mainstream stats in Australia, I feel like only like a subset of people know it. Most people actually don't know about, well, either they don't know or they don't talk a lot about it. So part of me, I have to say, in my biased way, because I have learned it, and I thought part of the mathematics around the mixed models was really beautiful. And I thought, why don't we actually teach this in undergrad? Because I would have actually enjoyed to learn this in the undergrad if I knew about it. And I guess in some ways, part of like working in the ag field, there's a part of where you can kind of understand some of the reasons how like statistical models are built, because you have more control over the units that you have. And so like if you have worked with human clinical data, there's a lot of noisy process in the way. And so it's a bit harder to understand exactly what influenced the outcome. And then there's too much unknowns in there. And there's some unknowns still like in the process in agriculture, but like I feel like there's a bit more chance to know what might have impacted the output. So I kind of like this aspect of it, and I thought the science was really great in this. And I kind of understood why, because a lot of the statistics really started off with Ronald Fisher, who was also working in agriculture. And it kind of made me go, okay, I think this was a time I feel like I finally understood statistics from the basics because of the much more control over the actual units that you have. This was also the moment that I really come to appreciate experimental design as well. Before that, I think when I went to my undergrad, experimental design isn't really taught in a way that that kind of was inspiring. It was more like a recipe kind of approach. Like, you know, you see split plot design, this is how you analyze it. You see Latin square design, this is how you analyze it. So like it didn't quite connect with me during that time, but seeing the application really helped me understand a little bit more. So at this point, it's a lot of like about the science part of it, but I'm starting to see the application a lot more grounded, and actually some people who will really directly need the statistics output during that time. And then I really like the passion that Brian actually brought on with this particular area. So I kind of wanted to continue along this area. And so I started my lecture position at the after my postdoc at the School of Mathematics at University of Sydney. So this was a 4-year fixed term contract. I did end it 1 year early, as you can see from the date. So here what happens is that I taught like very classical statistics, intro to statistics. So I taught hypothesis testing. I taught like applied linear models. So this is a part where you teach experiment design as well, but like in a very recipe way. And it's mostly focused on actually the linear models itself. But it's very rooted in the traditional statistics way. But I did actually make a lot of changes in some of the assignments so that I felt like it's more project-based rather than, you know, like kind of like seeing if they can actually understand like how to fit particular specified methods. I have to say I was really, really fascinated with experimental design mixed models back from my postdoc time. Mixed models where you can actually, like, you kind of think about how your observations are correlate with each other. And then basically you've got to kind of build in that correlation in a way that represented as in a covariant structure. So that was really intriguing to me. And also experimental design really fascinated me with a lot of influence from Brian at the time, who actually kind of made a point that if you don't get the design right, you might actually get rubbish data, and it doesn't matter how fancy your model is, your data means nothing, right? So there's a part where, because I want to actually do something that's impactful, to me, I thought experimental design seems to be an area whereby actually you can make a lot more difference than focusing on the analysis side of things. Because once you have the data collection scheme really written out properly and things go according to the plan, there's some perhaps analysis that becomes redundant, or perhaps like, you don't need to come up with a way to circumvent some of the issue that was in the design aspect. So I started to go into like conferences, and then I'll go to every experimental design sessions, which there was not many, by the way. So in that sense, I could go to pretty much all of it. And I will just listen to experimental design talks as much as I can at the conferences. So I did that for actually like a few years, 2017, 2018. I started thinking about design back when I was doing postdoc as well. And so it was sitting in my mind. I didn't know how I can contribute within the area, but it was always in the back of my mind. And same goes with mixed models. It's always kind of in the back of my mind. At the same time, or similar time, I was really, really impressed with the impact of tidyverse. So if you use R, you probably know it about tidyverse. And this compromises ggplot2, dplyr, tidyr, and so on. And these are basically a set of packages in R that are meant for data science, and you can consider them as cognitive tool. Now, ggplot2 is founded on the idea of grammar or graphics by Leland Wilkinson. And it's kind of like trying to reimagine the way that we specify plots. And the way that we do plots, instead of like a recipe approach, whereby you go, oh, okay, this is a pie chart, this is a bar plot, this is like a histogram and so forth. You kind of have this way of representing graphics in a way that's based on its element. And the part that really, really made me think this is actually quite clever was a moment that when you get a stack bar plot, and then you change the coordinate system from the Cartesian coordinate to a polar coordinate for the y-axis, you get a pie chart. So this transformation from going from a stack bar plot to a pie chart made me think, okay, like I knew they were kind of like showing the same quantities in a different way, but instead of thinking this is pie, this is a bar plot as some kind of separate parts, they're kind of integrated together. And we can think of this way because the way that we reframe things are now like specified on its elements instead. And I thought, oh, okay, this tool is actually promoting ways of thinking about plots. And given like ggplot2 is immensely popular, I thought this is quite interesting because in some ways, a lot of people are picking up these packages, and then they're now, in order to get the plots that they want, they're forced to put in themselves in that framework. So in some ways, you are actually promoting the average people who use R to actually think about plots in a certain way. And hopefully that's a high order thinking about plots. So it was kind of interesting to me because it's sort of like training people to think in a certain way by using tools. dplyr and tidyr also were So dplyr was founded on like similar concepts in SQL. So I think compared to the statistics world, I think the database world is ahead in this space. And they have a way of representing databases, which Hadley Wickham, who is the creator of this packages, actually expanded upon and made the package dplyr. So these things are rooted in certain principles or ways that we can rethink about how to do the cleaning of or wrangling of the data or plotting of the data. So it's not the mainstream statistics research, or at least the ones that you see in top 4 journals. But I thought just the impact it's making is quite impressive. So I invested a lot during that time to really learning programming a bit better. I did a lot of HTML, CSS on the side. And then I started making R packages and using Twitter a lot. During this process also, I was involved as an assistant secretary, then eventually secretary for the Statistical Society of Australia New South Wales branch. So there's a side of where I got to, through being in the committee, kind of get to know more of the statistics people out there. And also it's a moment where you start thinking about how do you what kind of events do we put in? What do we do to make it so that, people can, learn certain things? So I think that this moment actually kind of helped me see a little bit more, put a perspective on how things are actually run in terms of societies. Now, during 2018 to 19, this is a moment I have to say I had a lot more recognition, where some things I did in AgStats got recognized. In particular, when I was at the International Biometrics Conference in 2018, I gave a talk, and this was about auto selection of fact analytic model. I won't go through the slides, but this talk essentially caught the attention of a professor at the University of Tokyo in the biometry lab. And he invited me to deliver workshops at University of Tokyo. And there I met people like Gota, who was an assistant professor, who's now an associate professor of quantitative genetics at the US. And this gave me kind of opportunities to, work with people outside of Australia a little bit as well. And so it was kind of a nice organic way of things happening. And I guess in some ways I wanted to share that because if you're, trying to build connections, going to conferences like this was actually, it really worked and it was really nice. So that was a part where things just kind of organically improved in making networks. And then the other thing where I got a bit more recognition was in the R community. So partly, so Dr. Ihui Xie, who you may know if you use R, as the author of Nita and R Markdown maintainer, he wrote actually a blog post about me, which you can find there. And then he basically, commented on my hacking ability. And also at around similar time, or a little bit after that, Hadley was giving a workshop at Sydney. And he's the creator of the Tidyverse. And he asked me to be the teaching assistant. And actually, it was really a great opportunity because his workshops cost over close to 2,000 Australian dollars for a 2-day workshop. Wouldn't have been able to afford it. And because I was a teaching assistant, I got to go in for free. And then that moment was actually quite interesting for me because I think at that point, I was programming in R without really understanding any kind of computer science principles. And then so in that workshop, I think I got to see how Hadley thinks and operates. And that's when I started thinking, oh, okay, I guess this is how you would think about it if you are very serious about programming. So it was that exposure. Like Hadley has written books, and so if I had read his books, I probably would have known this, but I clearly did not read it in fully, so I did not. But him giving it and seeing how his thinking process during that time was quite influential for what I have come to do afterwards, essentially. I also got noticed an invitation from Douglas Bates, who's really well known if you are as a creator of LME4 and LME. And that time he was doing this cooperation group on statistical models. And he invited me to come to Germany for 2 to 3 weeks, and it was all paid for. Unfortunately, this was in 2019, end of 2019, the invitation came, and I was supposed to go in 2020. So it actually didn't end up happening. So it was a bit of a shame. The other thing was that also that was more notable was that then I got sort of like a invitation to really apply for the Monash job. That's where Dai Cook, who was Hadley and Yuhi's PhD supervisor, wanted me to come and join Monash. And then at that time, that was 2018. And then my thinking at the time was, no, wait, I still have 2 more years at UCID. I'm not going to apply. So I said no at the time. So I'm not looking for a job at the moment. But I changed my mind because I think I really wanted to get into more the statistical software area. And I thought, okay, Dai is Hadley and Yuhui, and I love Hadley and Yuhui's work. So it's like, let's go there because that might be a good opportunity to really like have more growth in actually doing statistical software development. Now, all this, you might be wondering, how did it come about? And this is really comes down to the usage of Twitter, that it works so well for me that I even give a talk about it, how to like kind of use social media. And this talk, you can actually find it on my website. But essentially what happened was that I shared a lot of what I learned and a lot of the packages that I built, which are very small and tiny things. But I kind of shared it on Twitter. And then it somehow reached people. And so that's sort of I feel like it worked really well. Now I have to say I can't give the same advice now because the fact that Twitter was really, really good for academics, I reckon, during that period. But since it's got sold to Elon Musk and it's become X, I feel like Twitter's have really gone down. And I don't know what's happening in terms of social media community. I don't feel like there's much more going on Twitter. So it's not the same as that time. But actually just like, showcasing your skill set so that people are aware that you exist. And then people know what kind of skill set you have. Just help me get that notice from people essentially. And then so in part had opportunities and job out of it essentially. So I did interview for Monash, and that was early 2019 that I received the job offer. Soon after that, I actually had an idea. So I think it was like around somewhere March or April period, I had an idea, which is the package that I have developed, now come to known as Edible. Well, actually it was called Edible back then as well. And I refer to this as the grammar of experimental design. And this is sort of like the work I felt like so far I've invested for 4.5 years now, and still continuing to invest in. And you may have seen this because I've been, talking a little bit about it too much. And this is my latest one that I'm talking about it. And I'm just going to give you like quick overview what it is for those people particularly who don't know about it. Edible is kind of inspired a lot by the grammar of graphics, ggplot2, and where you kind of like that one you think plots as defined by its element, but edible is a case where you kind of think experiment is designed by its elements. And in particular, there's a lot of challenge in experimental design because you've got like whole lot of people involved. So I'm just going to go through. Got the statistician, the domain expert, technician, the analyst, and so forth. So a whole lot of people involved into this, and there's a whole lot of communication challenge to it. So it takes a while to even formulate the understanding of what that experiment, like the data structure should be, right? And so like with Edible, what happens is that when you kind of specify the design, you think of it as, again, like an object, just much like what ggplot2 does. You think of plots as an object and you kind of build up on it. So here I initialize the design, and then based on this, on the description or your communication with the domain expert, you start to kind of dissect what kind of units and treatments you have. So here, diversity, I have 3 levels of diversity. The units are plot and subplot. Subplot is nested in there. And then like you kind of build it up element at a time. This is like the mapping between the treatments to the units. And so in some ways, like the way that I kind of thought about this is that it's sort of helping you understand what your experiment is about more based on its elements rather than thinking on a recipe kind of approach. Which is actually, if you read the literature, a lot of people say that, but in practice, still these recipe kind of design is very, very prominent. So this was sort of like the thing I've been working on for 4.5 years. And finally, yeah, it's coming to at least one part of the end, although I can imagine just expanding more. So you can just, there's a lot of like slides I've made for this. So you can find these like in general on my website. But that was sort of like the idea, and it's probably something that I'll be working on it for many years to come. But this was something that I formulated in there. And this is really because when it comes down to it, I had that fascination with experimental design. But also at the same time, I was really impressed with tidyverse. So it became like that mesh of like the different concepts that I was interested in at the same time, but also driven by the fact that I wanted to do something impactful. So it actually did take many years before I actually came up with that particular idea. And then I started my job at Monash. So I moved to Melbourne shortly after moving, and then maybe I should hurry up here because it's already 3:50. So I moved to Melbourne. Unfortunately, had pandemics, lockdowns. As part of like, you know, the Master of Business Analytics, I created many things. So these are really non-standard subjects, what called data, exploratory data analysis, communicating with data. And then so all these kind of things were non-standard from what I've done, very non-classical statistics. And I also, you know, did like service work during that time, which was involved as vice president and president for the Statistical Society of Australia Victoria branch. Internally, we made a lot of changes. We use GitHub as a lot of operation under the hood. And as part of my agenda, I actually did try to get more recognition for statistical software because I think it's still not really regarded as great currency in terms of academia. So I proposed like creating the Diet Cook Award during that moment, which is a student award for open source statistical software. And we just have the 3rd one running at the moment. So please apply if you are a student and done open source statistical software. And also at the same time, propose the creation of SSA section on statistical computing and visualization. So that's sort of like where I really want the software to be more recognized as proper research output in the world of academia. So trying to do something that will actually realize it in reality rather than just have a wishful thinking about it. I won't talk too much about that because of time, but so in 2022, I have to say, so part of it is that I did create a whole lot of teaching and whatnot. And this time I was in the Department of Econometrics and Business Analytics at Monash. I have to say, I was actually feeling dissatisfied. And so I actually voiced this in early 2022 to senior members. And particularly because I don't have a business background, it was like I don't align very well with econometrics and business analytics. And in particular, I had issues whereby they told me, like in certain Monash Women in STEM, that I can't join because of the fact that I was in the business school. So it didn't feel like it was the best place for me. And so I actually started thinking about leaving. But because my sabbatical was approved during this period, I decided that, maybe I'll think about it afterwards. And in order to concentrate more on the software side of things, I actually started doing things like brown bags and happy hour that's centered more on the programming side of things. But I think in the end, I feel like it didn't work out quite well and it was too much effort, even though I think people were nice. And it's not like I felt like people locally were excluding, but I felt like it was too much work. And so when I got approached for a job at ANU, I did decide to leave. So at the moment, it's kind of new for me. It's only been like 4 months. So of which I actually spent quite a bit of long time overseas, about like 6 weeks. So I haven't been here that long. And so at the moment, like what I'm doing is just concentrating on writing up things. So, I have just submitted a paper. So if you want to read more about the Edible, you can find it on arXiv. And also essentially working on the next set of paper. So now it's like a time where I actually finally finishing up some of the work I've been doing and I'm hoping to publish it. I know that it's already 3:55.
Yeah.
So maybe I will stop there and I'm happy to go back, of course, to like answer any kind of questions.
Yeah, thank you very much, Amy. Yeah, it was interesting to see your academia, part in academia, yeah, and how your career scaled up. So I think we're ready to take questions, and feel free to jump in, raise your hand, and ask questions. So feel free to write your questions in the chat as well if you want. Meanwhile, I will ask a quick question about the learning curve of the for the tidyverse packages, let's say, or ggplot2, and how do you think it's the learning curve for switching from planar to that set of packages, let's say? Do you think it takes some time to get used to the new syntax, and how quickly do you think you get used to it?
Yeah. So it depends on how you want to code it up. I think the learning curve is if you want to stay in the tidyverse kind of framework. So our studio, now called Posit, I think they've created a lot of ecosystem around their language, and it has become a bit of a dialect, I have to say. And this learning curve for this is actually a little bit high, I have to say. So even though I got the idea, it actually took me a while to learn how to use it. So they have concepts. So there's a package called rlang, which implements part of the tidy evaluation. There's tidy select, which actually does a selection. So that powers the selection that you see in dplyr. And then there's a concept called vectors package that they've got. And that's sort of like thinking about vectors and it's sort of like different classes and how to record it. And so in order to do Edible, you really got to know how to do the vectors package. Because when you get the table out, the way that it's outputted is built upon that. And then again, also it's extended upon Tibble. So you need to learn that. So there's a whole ecosystem of packages. You actually have to really, really research and understand how it works. And there are documentations here and there, but it's not really like something that a lot of people work on. So you do kind of have to look at like the source code and like understand how it goes here and there. So it's actually quite a lot of work to get to this stage, I have to say.
Yeah. Thank you. So we have a few messages in the chat. Let's quickly go through them. First of all, there's Stanislaus thanking you and saying, well done on your speaking about the Women in STEM award. It's so awesome when people ask openly and transparently about their journey. Yeah, I second this comment actually. And then we have a question from Daisy who's asking, do you have any resources for a good introduction to experimental design?
So there are books. I would recommend Rosemary's Bailey's book on comparative design of experiments, especially people who have a bit of a mathematical background. I think that's a good one.
Okay. And then we have a question from Olivia. Hi, Amy, fantastic talk. I was wondering whether, as an academic, you have to apply for grants and how hard it is to get funding for projects focusing on creating app packages or statistical tools. Yeah, very good question.
Yeah, that's a good point. So there are avenues for this. So there is a consortium where you can apply, and I have gotten it's not a huge amount. It was like about $6,000 from them. So if you have something, you can give that a try. And then the other ones are, so for those people who have more well-established one, and particularly who works in the biomedical area, there is a Chan Zuckerberg in a grant. So you could have a look at that. I know that Gordon Smythe got the pretty large amount of money for like the development and maintenance of Lima. So there's some here and there. And I think nowadays there's also an award now. So if you're not aware, so the Die Cook Award is more for students in Victoria and Tasmania, but there is also the Venables Award, which is by the Statistical Computing and Visualization section. So you should definitely check it out. Like if you have a well-established software, well, it's also for new developers. So I guess it can't be too established in that sense. And so I think the landscape is making it a little bit better, but it's still got a long way to go to have it as equivalence as like a research paper.
Thank you. Yeah. So we have a bunch of questions left. I wouldn't mind staying here longer, but since we're running out of time, maybe it's already 4 p.m., but briefly, I would say maybe let's go through the mentoring program very quickly, because Elizabeth is here and could talk about the mentoring program. And then if you'd like to stay a bit longer, we can continue answering questions. What do you think, Amy? You have 5-10 extra minutes to spend with us?
Yeah.
Perfect. Yeah. So maybe I would ask Elizabeth to share the material for the mentoring program and maybe going through it very quickly. Because we're getting quite a lot of questions now and they're quite interesting.
Yeah, thanks very much, Amy. It was a fantastic talk and really great I echo everything that's being said in the chat. It's been a really brilliant chance to hear about your career. I'll just be really quick. So I'm Lizzie Korovar, or Elizabeth Korovar. I'm one of the co-chairs alongside Karen Lamb of the SSA mentoring program. And we are currently, we have the open application period for the 2024 program. So I have a slide, but really the main thing is that there's a link. So if you are keen on joining the mentoring program in 2024, we do have some space open. But with the period of time that the applications are open for won't be open for too much longer. So currently it's sitting at the 30th of October, so Monday next week. We'll probably extend that by 2 weeks. but the sooner you get in, the better. And that's both for early and mid-career researchers who'd like to be mentees, but equally, if you are keen to be a mentor, we would also very much love to have you a part of the program. And that's all. The link's in the chat.
Thank you very much, Lizzie. Yeah. I think for those who would like to stay tuned, we can continue answering to the questions in the chat. And so I will get back to the question of Kristen, I think. That's where we stop. Kristen said, thank you, Emmy, for sharing your experience. What would be the most important advice for people who is trying to start to write their own package?
Learning basically, and this is where I learned from Hadley actually. So let me pass it on because he will be naturally the best program out there. So what I have learned during that workshop is that you really have to master the keyboard shortcuts. And part of the reason for this is that, so there's going to be, when you make our packages, you keep on like repeating the same operation again and again. And if you, like, if it takes, like, you know, even if it takes 1 minute for you to just get started, like you repeat this daily, it adds up. And so one of the things I did notice with Hadley when he was operating is that he's super fast. And that's because like he knows all the shortcuts in order to, you know, start writing up a package. So I think that's like, you got to revisit your workflow. Like when you build your packages, like how, or like even, and this doesn't apply just to your package development, even like, you know, writing papers or doing all your other activities, like what's the time costing factor? And what's like, so like build up like a kind of routine so that you can do that quickly, because the quicker you can do it, essentially, you are more likely to get started in the actual thing that matters.
Very good. The next question is from Xi Jingfu, who says, hi, Emmy. Thanks for walking us through your journey. You mentioned many examples of people reaching out to you, which led to new opportunities. As an early career statistician, how can one go about building those connections?
Yeah, so definitely it helped. The Twitter part helped. So normally I think what really helps is that if somebody can kind of like it works more for networking. And so if you're early career, generally the person who can really connect you with other people is your supervisor, because your supervisor will have been the expert in the field that you're probably working on, and they will have the natural connections. And then having the advocacy of your supervisor, I think, is actually a shortcut. So I didn't really, like, I had part of it, but not fully. And that's where the Twitter was much more influential for me. And that's more like a cold one, right? Because you don't have direct connections with people. So somehow, like, I think if you have, like, if you can connect some way, so networking events, being involved in society is also helpful, because you naturally then talk to other people as well. So I would say, you know, if you don't do social media, at least go to actual in-person events and talk to people.
I agree, but Twitter has changed quite a bit.
Twitter's not good anymore. I would not recommend it as much.
Yeah. And then Farzana says, thanks, Emmy, for sharing your journey with us. Very inspiring. I'm also trying to update how we teach experimental design in undergraduate courses in Murdoch University. Would you be able to share the principles you have created or followed to improve experimental design teaching? Could you help me? You could help me a lot. I can send you an email afterwards if that's easy. So I guess you could get connected with Farzana.
Yeah, it's a bit of an agenda. I have to say, so Rosemary's book is good, but I think there isn't actually like a good book out there. It is a bit of a gap. And I am actually writing a book called The Grammar of Experimental Design. It is available on the like on my website. So this one here. But like it's not ready, and it will take me a while. Maybe at best. I don't think it'll be finished next year, but maybe 2 years down the line.
Okay, we have a bunch of compliments that I second and thank yous. And maybe I'll just end with this one. Alex Shaw says, great talk, Emmy. Your comments about the relative importance of experimental design and how it is overlooked resonate strongly. Your contribution to thinking about experimental design is really valuable. Looking forward to your talk at the ASC.
And Alex knows because he's a stats consultant. I think consultants really know this really well.
And in fact, yeah, the ASC, the Australian Statistical Conference, will be one of our next events organized by the Statistical Society of Australia. If you don't know, it will be running from the 10th to the 15th of December in Wollongong, in New South Wales, jointly with OSCOT. So the Australian Conference on Teaching in Statistics. I'm mentioning these conferences because we will have an event for early career and student statisticians on the 12th of December. So we will go to a brewery all together near the beach, and we will have a chance to finally meet up, possibly all together in person. And we have a few more events we could advertise. I think the next webinar of our group will be on the 16th of November, but I don't have the details available at the moment. I think we are still finalizing them. And you can check this website for the list of events run by the Statistical Society of Australia. Sorry. Yeah, let me post it here in the chat. Okay, so yeah, don't forget the mentoring program and the link to the list of events organized by the SSA. So yeah, it's 8 minutes past 4 p.m. here in Canberra at the ANU, and I think it's probably a good time to wrap up and thank Emmy again for this excellent talk and everyone else who was here today. It was nice to see so many people online, and hopefully I'll see you, some of you at least, in person at the ASC or at other events. Thank you, Emmy. Thank you again, everyone.
Hi, everyone.